All right, question number 9. So using the sum of cubes rule, a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. By using this identity, evaluate the limit as x approaches the 5 of x squared minus 13x plus 40 divided by x cubed minus 125. If the limit does not exist, enter DNE. Okay. So till this point, we really haven't talked about how we can evaluate limits. And this is a good question to showing some techniques of how to evaluate limits. Okay. So let's first write out our limit here, which is limit as x approaches 5 of x squared minus 13x plus 40 divided by x cubed minus 125. So the first technique that we can use to evaluate limits is to simply plug in x equals 5 into our function, right? So here, if we plug in x equals 5, we have a good chance that we'll be able to evaluate the limit. In this case, we're not able to because the denominator function becomes 0, and we have an indeterminate form, which is something divided by 0, right? So we can't do that yet. So the other technique that we want to use is we want to simplify our function here, our expression. We can do that by algebraic cancellation. We can do that by factoring the numerator and dividing it and simplifying the numerator and denominator. We can also use conjugates to get rid of square roots or complex numbers. We can do a lot of different things, right? So these are different techniques that we can use to help us to calculate or evaluate our limit. So we're going to use the sum of cubes to help us calculate this limit. So this is equal to the limit as x approaches 5. If we use the sum of cubes here, we know that the denominator can be alternatively written as x minus 5 times x squared plus 5x plus 25. Okay, we can alternatively write our denominator as this. Okay. Next, we can factor at the top, right? I believe it's factorable, right? So x squared minus 13x plus 40 is also equal to x minus 8 times x minus 5. All right, so if we do that, then we get limit as x approaches 5 of x minus 8, x minus 5. Divided by x minus 5 times x squared plus 5x plus 25. Okay, now we can factor out x minus 5, right? We can cancel that out, and we're left with the limit as x approaches 5 of x minus 8 divided by x squared plus 5x plus 25. Finally, let's try to plug in 5 now, right? So if you plug in 5, our denominator is not equal to 0. It's actually equal to 25 plus 25 plus 25, which is 75. And the top is equal to negative 3. So now we evaluate our limit, which is negative 3 over 75. So now we know that this function as x approaches 5 is equal to negative 3 divided by 75. Okay, so this solution